Behind the ordinary objects which surround us in our day-to-day lives lies something extraordinary. Incredible stories of ingenious solutions to problems most of us never knew existed. So, what mysteries are concealed in everyday things we take for granted? Tires, the excavator, ports, newspapers, and the contact lens. 5 ordinary things, 5 extraordinary stories, now revealed as we go behind the scenes, inside the machines to find out, how do they do it? The only time we give it a moment's thought is when it's flat. And yet the rubber tyre has played a massive part in shaping the modern world. We travel more today than ever before. And to help us move with ease and speed, we've come to rely on this deceptively brilliant invention, the tyre. Here at the Pirelli test track, just outside Milan, Italy, technicians test high-end tyres designed specifically for the fastest road cars in the world. Tyres have one heck of a job. They must be durable, able to run for up to 128,000 kilometers apiece. They must grip the road at all speeds and in all weather. They must support a heavy load, but give a comfortable ride. How they manage this is a fantastic story of chemistry and engineering. The action begins here at Pirelli's high-tech plant, with some state-of-the-art industrial robots and some ingenious smart technology. The tyre consists of various elements. The body begins life as a dual-layered rubber strip called the ply. Ply is made of rubber mixed with a synthetic fibre, more often associated with home furnishing, rayon. The rayon fabric is there to stop the rubber from tearing apart under pressure. After the ply come the tyre sidewalls. These have to absorb the weight of a 2-ton car. So to do their job, the sidewalls must have something more than just rubber. That other component is steel. Here, a robot is inserting steel belts to the inner part of the sidewalls. On cue, the smart robots bring together the tyre ply with the sidewalls. They work with incredible precision. The match is invariably perfect. The join appears seamless. Once the 2 sections have come together, another thick layer of rubber is rolled on, completing what they know in the trade as a green tyre. Green tyres look pretty much like the tyres on your car, but they're still missing a crucial feature: tread. The design of tread is essential to the success of a tyre, but there's something rather surprising which tyre manufacturers look for in a tread. It has to make the right noise. In particular, it shouldn't make too much noise. In Pirelli's R&D lab, this tyre is about to face a range of audio tests which will determine whether it is fit for the open road. If you listen carefully, you'll hear what the engineers are looking for. Nothing. The sweet sound of silence. At Pirelli, this is a serious business. The chamber is very heavily soundproofed. The tyre must meet exacting acoustic standards.
If the technicians feel the carcass is too noisy, then we intervene on the tyre to lower the noise emissions.
The tyre is placed on a treadmill, which simulates driving along a highway. Highly sensitive microphones are placed around the tyre and connected to a computer, where the audio signals are converted into sound waves. For this tyre, it's so far so good. But now it is really going to be put through its paces. It's about to be pushed to the limits in Formula One racing conditions. Our modern lives depend on trucks, buses, cars and planes. And all these depend on tyres. Modern car tyres are expected to last a staggering 128,000 kilometres and still be safe. So, how do they do it? This is a normal road tyre, but it's about to be treated as if it were in a Formula One race. Once the tyre is locked firmly into place, the technicians punch in the weight of an average town car. Then, the speed begins to increase. The idea is to see how the tyre performs under extreme circumstances. With the naked eye, it would be impossible to see what is happening to the tyre, even at slower speeds. So, Pirelli technicians have come up with an ingenious solution. At the flick of a switch, the speed chamber is flooded with stroboscopic light. When set to the correct frequency, the flickering light makes it look as if the tyre has stopped moving. This allows the operators to inspect the tyre as it's turning. But today, the team is testing a new kind of tyre and have decided to push it especially hard. The speed reaches a nosebleed-inducing 350 kilometers per hour. That's faster than a jumbo jet's takeoff speed. Incredibly, the tyre remains intact. It's passed with flying colours. Once a new tread is approved, it must be applied to another generation of tyres. That requires a spot of baking. This is a curing oven. Its robotic brain calls out for another half-finished green tyre. Each oven contains a large inflatable bladder. As the bladder expands, it'll push the tyre against the mould. Steam will then be pumped into the bladder, and the tyre is cooked at 135 degrees centigrade.
This is the green tyre is pushed into the mould and the tread branded on.
In just 12 minutes, the tyre will be complete. As the machine opens, the tyre gently falls out of its mould. Another tyre, ready for another 128,000 kilometres. Behind the ordinary objects we take for granted lie some extraordinary stories. Coming up, the excavator. the essential tool for building everything from roads and tunnels to bridges and buildings. Next, on How Do They Do It? As we get more and more ambitious about the cities we want to construct, the tools we need must be more powerful, lift heavier loads, and break harder materials. Most machines excel at one task, but there's one which can turn its massive hydraulic hand to almost any major construction job. The excavator. Commonly portrayed as mere diggers, these monsters do much more than dig. In the trade, they're called tool carriers, which means one day it's a crane, the next it's wielding a tree-slicing wheel, and the next it's smashing rocks. The excavator is the #1 heavy-duty, all-rounder building power tool. It is the decathlete of construction. But how do they pick up such gargantuan loads? How come they don't topple over? And why don't their arms just snap off under such weights? How do they do it?